So this lecture is about descriptive statistics, the tools that are used to describe a set of results, sort of offer overall conclusions. So the aim here is to summarize a vast quantity of data in a succinct and meaningful way. There are two large categories of these statistics. One is typically referred to as frequencies. The frequencies characterize the distribution or proportion across response categories, and frequencies are appropriate for category measures or ordinal and nominal level variables, such as male, female, red, blue, yellow colors. So frequencies would characterize a large data set in terms of how they're distributed across those categories, either proportions or raw scores. Descriptives are used to summarize data in terms of central tendencies and dispersion. Descriptives are statistics appropriate to interval and ratio scaled measures. For example, income, beliefs, attitudes, sales levels. Much more effective to describe, say, a set of 2,000 different incomes in terms of the average, rather than to rattle off each of the 2,000 different income scores. So let's take frequencies first. So frequencies, again, refer to summary descriptions of the distribution of category measure data. These data are coded and labeled, and the codes and labels are typically not the same. Usually they're coded numerically, even though they're category measures. So for example, if we were coding home address in say 6 regions of the United States, we might use the number 1 to indicate New England, and the number 2 to indicate Middle Atlantic, and the number 3 to indicate the Southeast. But those numbers don't have much use to us when we're talking about the data, so we're probably going to use the labels New England, Mid-Atlantic, and Southeast when we're talking about the data. And we have to be careful to avoid using those numbers in any mathematical computations, because the numbers are actually just names. They happen to be easy to use when we're coding data for analysis. Frequency counts are the numbers of respondents who land in each category. So the number of respondents who reported living in New England, for example. Frequency percentage is that number over the total number. So there may be 11 people who said they live in New England, and that may represent 4% of the sample. Missing values are those respondents who participated in the survey but did not respond to this question. And there are ways to adjust for that, and we'll talk about those. Cumulative frequencies are frequencies are the frequency percentages for each category summed up. And although they may be used for nominal data, they're more readily more appropriate for ordinal data. So for example, if you were categorizing people by their distance from a store, the home location as a distance from the store, you might have the categories within 1 mile, 1 to 3 miles, 3 to 5 miles, and more than 5 miles And you could report the cumulative frequency for all of the lower categories up to, say, 5 miles, and say that 70% of the people live within 5 miles. So you're simply combining the three categories that are up to that point. There are a number of ways to represent these data, graphs and charts, and increasingly sophisticated methods for using the computer to show graphs that allow you to click on various points and reveal information underneath. How to do that is another aspect of research that's more art than science, and gets improved through experience. I'll talk a little bit about recoding frequencies from interval data. Many times measures are taken on an interval or ratio basis, but in order to interpret them, or especially to display them, they get recoded into categories. This is an example of category measures of education. So you see the categories on the left there are some high school graduate, some college graduate, postgraduate, and then a refused to respond. The refusal could be an outright refusal. It could be simply a respondent's overlooking or missing this question, so it might better be labeled as missing. And you can see in here the code value. So these are the numbers that are entered into the data set, 1, 2, 3, 4, 5, and 6. Again, those numbers don't have mathematical meaning. There is an ordinality here. High school grad is more education than some high school, and 2 is greater than 1. But there's no interval scale implied. And certainly the 6 for refused or missing has no meaning relative to 5, 4, 3, 2, or 1. The next column is frequency. These are the absolute number of respondents who fall in each category. And you can see that there are 671 in total, and 57 of those are missing values or refuse to respond. The next column is percentage. So that 28 is 4.2% of 671. And the 101 high school grads represents 28.5% of the 671. And you can see those cumulated to 100%. So the final column, 4.2% is 4.2%. And then high school grads represent 32.7% cumulated. So 32.7% of the sample had either some high school or were high school grads, up to the 100% who had some education or refused. Now that or refused part can be problematic, and so typically the refusals or the missing data need to be removed for some of the presentation, some of the analysis. So here we see the same table modified, the same codes, the same frequencies. So we see those 57 people who were missing or who refused to respond. And in terms of percentage, we see that that's 8.5% of the total. But then we have an adjusted percentage which removes the 57 from the 671 and uses the remainder, 614, as the total. And now we see that the 28 people who were 4.2% of the overall total are now 4.6% of the adjusted total, and so on. And now we see the cumulative percentages total of 100% when we get to the highest level of education, postgraduate. There are many ways to display or illustrate frequency results. I favor keeping it simple. So this is a bar graph that shows the percentages for each category. So you can see that some high school 4.2%, the high school grads 28%, whatever it was, and on the far right they refused at 8.7%.